All right, so this section is over solving inequalities. All right, so the inequalities are less than, greater than, or less than equal to, or greater than or equal to. Less than symbol looks like an arrow pointing to the left. The greater than symbol looks like an arrow pointing to the right. These will be recognized as strict inequalities. Strict inequalities. Now, the ones that are not strict inequalities would be the less or equal to. So you'll still have your less than symbol pointed to the left, and you just toss an equal to sign up under it. Greater or equal, greater or equal. You take your greater than symbol and toss your equal sign up under it. All right, these strict inequalities, if you're looking at the information down below, strict inequalities, they get parentheses. All right, and these others, they get brackets. All right, so strict inequality here, parenthesis, and this is not a strict inequality. And the second example, so it gets brackets. All right, let's move on to the next slide. Okay, it wants us to write each inequality using an interval notation. All right, so first thing I want you to do is look at we're gonna do graph and interval notation. All right, it says to graph it and do interval notation. So all you need is these two numbers. You have -2, and you write them in order from least to greatest, going from left to right. All right, and now you see those inequalities around that x are not strict inequalities. So that means you're going to get a bracket. What I like to do, I like to read this thing from the inside out. So I would look at this and I would say, this is x is less than or equal to 4, and x is greater than or equal to -2. All right, so notice I did not flip the symbol. I just kept the spacing of the symbol on the variable x. All right, the point is pointing at the 4. I'm sorry, the point that's the inequality that's paired with the 4. The point is pointed with the x. The inequality that's paired with the 2. The point is pointed at the -2. All right, so I would normally just put the rightmost one first, and I would shade until I get to the next number. And if I'm supposed to cross, if my shading would cross that number, we run into error somewhere. We're not crossing that number. Those numbers are endpoints in our values. And we put brackets because we have the or equal to sign. All right, let's look at the next example, part B. All right, so part B, again, we have two numbers there, 2 and 7. My x is to the left of 7, so I'm going to write my x to the left of 7 just for a visual. And that also says 2 is to the left of x. So that just told me everything. X is to the left of 7, 2 is to the left of x. And we put parentheses because it's not strict inequality. I forgot to put the interval notation for part A, so we're going to go back up here and put interval notation. What we just gave you was the graph, so boom, you use the information that you put on your graph to write an interval notation. So that's telling us x is between -2 and 4, include the values of 2 and 4. Part B is telling us x is between 2 and 7, but do not include 2 and 7. And C and D, they are performed in a similar layout. All right, so you have this value of 6. It says x is to the right of 6, and this is going to go on forever, shade forever to the right. All right, so now anything that goes forever is going to some direction of infinity. So since we have from 6 and to the right forever, we're going to infinity, positive infinity. Infinities, you never include infinity, so infinities will always get brackets. And boom, for example D, run another quick layout. Swing that guy to the left forever. And you have from negative infinity to negative 3. All right, let's move on to the next example. Now this example, it gives us interval notation, and it wants us to graph and write the interval notation as an inequality. So we're gonna start off by graphing and toss the numbers on the graph. X is between those numbers. So that says x is between negative 1 and 2. I put a bracket on 2 because that is a bracket on the interval notation. Now to write this as an inequality, I'm just going to take what I have on my graph. I'm going to put these numbers down. Okay. It says x is to the right, x is to the left of 2, it says. So I'm going to write that. Looking at the graph that we wrote, x is to the left of 2. But it's a bracket on that 2, so that means I'm going to put an equal sign on that. And it also says negative 1 is to the left of x. Little hint, your inequality symbols will always go in the same direction when you're dealing with combined inequalities. The inequalities go in the same direction. All right. Part B, we have negative 2 and 0. Brackets on both. X is definitely between those. Now to write that out in inequality format, I'm just going to write out the numbers and the variable. And now as x is to the left, if you look at your graph, you'll see x is to the left of 0, include 0. And negative 2 is to the left of x, include negative 2. And then we have 5, and it says go to the right forever. I'm going to shade. Do not include 5 though. Alright, so we're going to write our x. We're going to write 5. It says x goes to the right of 5. X is greater than 5. And same thing for this negative 1. Oh, I just wrote out what's present, which is not what I intended to do. And so let's toss this guy on a quick little graph. Here's 1. So go to the left forever. Went to the left forever. And we have x to the left forever of 1. All right. Move on over to the next. All right, so this non-negative property simply means if you square any real number, it will always be positive. For example, negative 2 squared equals, it will always be positive or 0. Positive 4. Positive 2 squared equals positive 4. 0 squared equals 0. So non-negative property simply says if you square any real number, it would always be greater than or equal to 0. All right, let's go on to the next. Time to solve these inequalities. We've gone through some quick little examples, but you will solve an inequality just like you solve a linear equation or any equation. We start off by we isolate the variable. That is the goal. So let's get variables on one side, constants on the other. Get yourself on over there with your other constant friends. You see variables are over here. And we have -6 right here. Alright, divide each side by -3. And we have x blank +2. And we have x is less than or equal to +2. And here's the reason why. When dividing or multiplying across an inequality by a negative, flip the inequality symbol. All right. All right. Again, get the variables on one side, constants on the other. So I have a variable, or then oh no, you didn't. Go on over that constant. So now you have 4x, which has a variable less than 2x minus 4. All right, 2x. You better get over there with those variables. Stop playing. And now we have 2x less than -4. And now to undo the multiplication, to get the variable completely alone, we have x is blank -2. I hope you did not flip that symbol, because we did not divide by a negative number. The only time you flip that symbol is when you divide or multiply across an inequality by a negative number. All right. When solving a combined inequality, I didn't mean to do that. Let's see, get that off of my screen right there. When solving a combined inequality, work from the inside out. You get the variable by itself, so that leaves us with -3 less than 3x less than 3. Next, divide everyone by the center, because you want to undo what's attached to the variable. So that's -1 less than x less than +1. Get the solution in the inequality, and it wants us to graph it. All right, the graph, we have -1 to 1. X is between those. It says x is to the left of +1. And you put parenthesis and shade in between those, because it is a strict inequality. Then we have, don't let it just look scary. We want to get rid of that denominator that's in the center by multiplying all components by that denominator. So I'm going to multiply the first component by this denominator, multiply the middle by that, and also multiply the last one by that. So we have 3 times 1. That gives us 3, less than or equal to 5 minus 2x over 3 times 3. 3 divided by 3 is 1, so that leaves us with 5 minus 2x. And then on the far end, we have 3 times 3 is 9. All right, we're trying to get that variable by itself, so we're going to deduct from the inside on all. That gives us -2 less than -2x less than or equal to 4. And I should have said less than or equal to 2x. Dividing every term by -2. All right, what did we just do? We divided every term across an inequality by negative. So that inequality symbol is going to flip for every being that is involved. All right, so there's your solution. When you graphing this out, you put your smallest one down first, because we write for in increasing order, ascending order from left to right. All right, so this is 1 is to x is to the right of -2. X is to the right of -2. And 1 is to the right of x. And put brackets because you don't have strict inequalities. Let's change the page. And then you have a little reciprocal property. Basically, reciprocal property, all it says is if A is non-negative, then the reciprocal of A, which would be 1 over A, is non-negative. Well, it's greater than 0. It's positive. If A is positive, then 1 over A is positive. Likewise, if A is negative, then 1 over A is negative. So what we have here, this 3x plus 6 to the -1 power is the same thing as saying 1 over 3x plus 6 to the -1 power greater than 0. Now, if we apply the reciprocal property, if that is greater, that should not be -1 power. That should be raised to the +1, because that negative exponent said move the base to the denominator. We move the base to the denominator, and it says just keep the value of the exponent. And that's the way we did. Now, I just wanted to clear that up. Now, if we apply the rules of the reciprocal property, we could take this example and say, oh, well, since that's positive, 3x plus 6 is also positive, and I can easily solve this, and that will give me 3x is greater than -6, and x is greater than -2. And when I graph that, I have one value that's I have in my mind, and I'm going to shade to the right. And if I'm going to write that in interval notation, I have one value that I'm going to write, and I'm going to the right to the positive infinity. That's it. Booyah. Next slide. Okay. Ohm's Law simply says that we have voltage is equal to a current times resistance. Voltage equals current times resistance, and it says an air conditioning unit is rated at a resistance of 10 ohms. If the voltage varies from 1 to 120 inclusive, and that word inclusive means include those values, what corresponding range of current will the air conditioner draw? All right, so let's write this out. Let's use this information that we're given. All right, so it says voltage is denoted by E. So I'm going to go right here, and I'm going to put an E for voltage, and ohm resistance is denoted by R, and it wants to know, all right, so if voltage is I times R, and it says voltage ranges from 110 to 120 inclusively, I'm just going to not write E because I need to see what makes up E. So I put in what makes up E, and now I'm going to put in this final component where it says resistance is 10. And I want to find out current. So if I want to find out what current is, which is represented by I will divide everything by 10 to get my current. And that tells me that my current ranges from 11 to 12 amps. And there you go. That's what we have for solving inequalities this time around. We'll do more in the future.